your matriculation, STPM. So I'm not going to talk too much about these. The 13 important vitamins. Vitamin E, retinol, B complex. We have B1, B2, B3, B5, B6, B7, B9, B12. Vitamin B consists of 9 type of 1, 2, 3, 4, 5, 6, 7, 8, 8 of vitamin. This vitamin B. Maybe you need to memorize every single vitamin in vitamin B complex. The rest is so very straightforward. A retinol, C ascorbic acid, and so on and so forth. The classification of vitamins, already. Fat soluble vitamin A, D, E, K, and water soluble vitamin. We have only vitamin B complex and vitamin C. So to make it easier, just remember that vitamin B complex only consists of 2, B complex and C. Water soluble vitamins generally involved in the cellular metabolism of energy supplying nutrient, which is fat soluble vitamin offered very specialized function. If to make things easier for you to get a grasp or to remember about this vitamin, when we talk about water soluble vitamin, most of the time, if not all, generally almost all the vitamins that are water soluble involved in the cellular metabolism of energy supplying nutrients. So if all this vitamin B stuff here, vitamin B complex here, provide a vital role in terms of giving your body energy, right? But not for fat soluble vitamin. The fat soluble vitamin have a very specialized function, which we are going to discuss later on. Okay, we go first. Water soluble vitamin. The name, it's soluble in aqueous solution. Water soluble vitamin usually contain hydrogen attached to electronegative atoms such as oxygen and nitrogen. Easily form hydrogen bond with water molecules, so we call it water soluble vitamin. This water soluble vitamin used as cofactor by many enzymes. For example, TPP, which are thymine pyrophosphate, is a cofactor by NAD plus and NADPV. If you already learned about carbohydrate metabolism, you know by now what these four NAD plus and NADP plus, paradoxal phosphate, biotin, etc. I hope you still remember from your carbohydrate metabolism lecture. And this water soluble vitamin not stored in the body. So because this vitamin cannot be stored in the body, you need to have regular supplies from your diet. So regular supplies are necessary. So that's why when you look, nowadays, because of the COVID things, we tend to be more, aware of the importance of vitamin C, because we have to get our body well prepared to combat all these virus, all these bacteria, right? So we take. It's good to take vitamin C supplement. So if you see at the back of the pack of the vitamin C supplement, it says that for adults you can take normally vitamin C that you can get from pharmacies. It says 500 milligram, right? So or maximum you can take 1,000 milligram. All right. So it's, if you see if you go to the vitamin sheet, daily required amount of vitamin, dose of vitamin C, your body doesn't need that much. Up to 500 is too much. 1,000 is a lot. But the things that why you need to take up to 500 milligram, for example, is because most of the vitamin supplement, for example vitamin C that you take from the vitamin C pills that you take will be flushed out via urine. Okay, so your body only able to, to absorb, some part of it, not all, not even half. So can you imagine if you just take 50 milligram for adults, and then after a while you urinate, all of those vitamin, maybe less than 10%, being absorbed. So that's why, they ask you to take up to 1,000, so that, in hoping that your body can absorb at least 30% of those 1,000 milligram vitamin C that you take. Because this is not stored in the body, so normally the toxicity of water soluble vitamin is very rare, right? Unlike the fat soluble vitamin, which are going to be stored in your fat and etc. So water soluble vitamin is not going to be stored, so that's why you need these regular supplies every day. All right, vitamin and function. Uh, Based on this figure, you can see here the role of all these vitamin, water soluble vitamin. For example, thymine. Thymine is vitamin B1. It's a coenzyme for thymine pyrophosphate. Its function as decarboxylation reaction. Riboflavin, vitamin B2, FAD, electron transfer. You learn about electron transfer chain and so on. This is, where riboflavin is, role come in. Niacin, B3, NAD plus, oxidation and reduction, uh, pantothenic acid, B5, responsible for coenzyme A, acyl group transfer, pyridoxine, B6, pyridoxal phosphate, carry out transamination reaction, cobalamin, B12, coenzyme for methylcobalamin, methyl group transfer, ascorbic acid, vitamin C, function as in synthesis of collagen, wound healing properties, biotin, biocytin, carboxylation reaction, folic acid, tetrahydrofolate for methyl group transfer. So these are, important vitamins, water soluble vitamin and their general function. Uh, but in this lecture, we're going to talk more rather than this, straightforward function. Same thing. All right, let's go one by one on the water soluble vitamin. I hope we can finish this water soluble vitamin, before the end of the class today. Vitamin B1. All right, vitamin B1. The active form of this vitamin B1, we call it is called as thiamine. Thiamine, vitamin B1. So this is the structure of vitamin B1. The majority of thiamine in serum is bound to protein, mainly albumin. Approximately 90% of total thiamine in blood is in erythrocyte. Okay, so you know that this thiamine bound to protein, albumin, and 90% of this thiamine in blood is in erythrocyte. So the factor is coenzyme is thymine pyrophosphate, or we could call it TPP, is a vitamin B1 derivative. Okay, this TPP functions as coenzyme for many enzymatic reactions. You go back to, your energy metabolism in your carbohydrate metabolism. You know what pyruvate carboxylase does. Pyruvate dehydrogenase, alpha ketoglutarate dehydrogenase, transketolase. So because you already learned this, I want to call names, to ask you what this. If who I'm going to call Nabila Afendi. Nabila, you here?
Yes, doctor.
So what's the function of pyruvate decarboxylase?
Mm, to make pyruvate.
Are you sure?
So. Yes.
All right. How about alpha ketoglutarate dehydrogenase? Oh, not you. I call other names. Can I get Irfan Hafiz? Irfan Hafiz.
Yes, doctor.
So, what's the function of alpha ketoglutarate dehydrogenase? You should know by
Uh,
now.
it's in the Krebs cycle.
Yes.
Okay. Wait, alpha. No. Succinyl. No. Oh. It's tend to succinyl CoA.
Are you asking me or you answering my question?
Answering the question. It's tend to succinyl CoA.
Is what? Sorry?
The alpha ketoglutarate. This enzyme will turn the alpha ketoglutarate to succinyl CoA in the Krebs cycle.
Hello?
Hello?
Irfan?
Hello?
I couldn't hear you.
Oh, do you get the answer?
Can you repeat because I couldn't hear you
Okay.
clearly?
This enzyme,
Mm-hmm.
it's turn the alpha ketoglutarate to succinyl CoA in the Krebs cycle.
Are you sure? 100%?
Uh, yes. Why not?
Oh, all right. Thank you very much. Where are you, Irfan? Are you in college or at home?
At home.
I thought you asked someone else.
Oh, okay.
Okay, thank you very much. So, yeah, as I mentioned earlier, water soluble vitamin play an important role for energy metabolism. So, when you see thiamine, for example, vitamin B1, these coenzymes involved in many reactions that, as you can see here, pyruvate carboxylase, PDH, alpha ketodehydrogenase, and transcrystallase. Okay. All right. So this thiamine important for energy from carbohydrates as well as proper nerve function in the form of acetylcholine and myelin. It also involved in to promote growth and good muscle tone, ATP production. Of course, when we talk about energy metabolism, at the end of the day, what we need is ATP, right? So, what source this vitamin B1 can can give you vitamin B1? Mostly fish sauce, liver, legumes, nuts, whole grain. All right, these are some of the main food that can give you lots of thiamine. So how about the deficiency? So the deficiency, you can lose of appetite. Of course, when you don't have enough vitamin B1, you cannot generate energy optimally in your body, so you will get weakness and tired. You can get muscle weakness, insomnia, loss of weight, because you don't have enough energy, and depression. For example, the well-known disorder is like we call it beriberi. It's very common in African continents, some of the very unfortunate area like in Somalia and so on. That region, they don't have enough supply of good source of food, quality food. So that's why we can see very in that area. So how about toxicity? As I mentioned, toxicity is very rare. So no known adverse effect if you get too much vitamin B1. Uh, as as we speak, there's no toxicity adverse effect that been reported. All right, next one, riboflavin. These are the chemical of structure of riboflavin, vitamin B2. All right, before this, maybe you only know vitamin B1, vitamin B2, but now you need to start calling them by their proper name as riboflavin for vitamin B2. It constituent of two coenzyme FMN and FAD for a variety of flavoprotein enzyme reaction. So vitamin B2 derivative FMN and FAD, which are the prosthetic groups. You know what is prosthetic group? I already I think I teach you carbohydrate metabolism. So prosthetic group involved in metabolic reaction. All right. For example, here FMN function as redox active coenzyme, various oxidoreductase, including an ADH dehydrogenase, like FAD, redox active enzyme, succinate dehydrogenase complex, pyruvate dehydrogenase complex, alpha ketoglutarate dehydrogenase complex. So where can you find the succinate dehydrogenase complex? Someone want to answer my question? Succinate dehydrogenase complex. In which pathway can you find this succinate dehydrogenase complex? Okay, I will call him. Tashmita. You hear Tashmita?
Yes, doctor.
All right, so where can you find this succinate dehydrogenase complex?
I think a citric acid cycle and electron transport chain.
All right, thank you very much. All right, I'm sure all of you, I hope that all of you know succinate dehydrogenase complex, citric acid cycle, etc pathway. So these FAD involved. So riboflavin, vitamin B derivative in the form of FMN and FAD, responsible for all these redox enzyme reaction in all of these, complex pathway for energy production, citric acid cycle, TCA cycle, and ETC. All right, so energy production, of course, carbohydrate, fat, and protein metabolism. Riboflavin also involve information of antibodies and red blood cell respiration, maintenance of good vision, skin, nails, and hair, alleviating eye fatigue. So where can you get this vitamin B2 from? Milk and milk products contains lots of riboflavin, eggs, beef, muscle, liver, and etc. All right. So how about the deficiency of these riboflavin can cause itching and eye burning, cracked sores, mouth and lips, bloodshot eyes, dermatitis, oily skin, digestive disturbance. So, and then again, toxicity, no known adverse effect. Okay. All right. The next one, just a second, I'm going to get some drinks. 1 minute. All right, you still here? Okay, we continue. So next vitamin in water-soluble vitamin, in vitamin B complex, vitamin B3, we call it niacin or nicotinic acid. All right. So so this vitamin B3 is another form of vitamin B3, which is a niacinamide or nicotinamide. So you can see here the structure of nicotinic acid and nicotinamide. The difference is on which is nicotinic acid contain acid OH here, while amide contain amide here. Same function, okay, but the different pharmacological properties. Okay, so although that niacin and nicotinamide they are very identical in the vitamin activity, but this nicotinamide does not have the same pharmacological in a way that these nicotinic acids contain lipid modifying effect, all right. So this nicotinic acid and nicotinamide is precursors for biosynthesis of NAD as well as NADP. So on the left here you have NAD, and on the right you have NADP, nicotinamide adenine dinucleotide, nicotinamide adenine dinucleotide phosphate. These compounds are coenzyme for many hydrogenases. So these two coenzyme participate in many hydrogen transfer process. All right. Important NAD, for example, important in catabolism of fats, carbohydrate, protein, alcohol in certain extent, as well as cell signaling and DNA repair also involve, NAD, DNA repair, and NADP mostly in anabolism reactions such as fatty acid and cholesterol synthesis. I'm sure that we already go through the function of NAD and NADP in carbohydrate metabolism, right? So you can read here. It can exist in two forms, which are oxidized and reduced form. When in NAD plus, we call it it's oxidizing agent. NADH reducing agent involved in cell signaling and DNA repair. So for NADP, lipid and nucleic acid synthesis require NADPH as reducing agent. So both are required by by the function for redox and reducing and oxidizing properties. All right, so let's see again the importance of niacin energy production. Niacinamide also important in energy production, maintaining nervous system. Both of them used to treat pellagra. Now it's very rare, especially in our country and all the developed country and developing country. Cholesterol lowering effect for niacin. Niacinamide treating osteoarthritis, improves circulatory problem, while niacinamide anti-inflammatory for treating acne. And adverse effect cause skin flushing, but this vitamin B3 has been reported to have some effect if you have it in excess. For example, of skin flushing, but niacinamide doesn't cause skin flushing, only niacin, right? So niacin, some of the receptor in our body is very this niacin is a good ligand for that receptor. Let me memorize. This receptor is involved uh, in the lipid metabolizing process, so that without niacin, this receptor cannot function very well. So when niacin bind to this receptor will get activated, and then there's a lot of going on under that, signaling properties, transduction cascade, in order to metabolize all these lipid. So we don't need much niacin for our, recommended daily, intake. Niacin is not a lot. For example, for adults, about 17 to 20, milligram is enough, and for infant, for kids, around 6 to 10. Okay, so vitamin B3, where can you get niacin from? From meat. Same goes with vitamin B1 and B2, fish, nuts, and mushroom. Deficiencies, it can cause pellagra, gastrointestinal disturbance, loss of appetite, headache. Headaches normally caused by not enough oxygen to in your body, insomnia, mental depression, fatigue, of course, when you don't have enough energy, age, muscle ache and muscle pain, nervousness, irritability. So this is how pellagra looks like. All right, next, vitamin B5 or pantothenic acid or pantothenate. Pantothenic acid is essential for the synthesis of coenzyme A. So the word is essential. Without vitamin B5, you cannot synthesize coenzyme A. You know that coenzyme A is very vital in your body in terms of energy, metabolism, and so on. So without this, uh, you know lots of things going on. You cannot process, and you cannot have your energy metabolism properly, and then at the end of the day, it's a very fatal for human. So we need pantothenic acid for coenzyme A. This is the structure of coenzyme pantothenic acid. It consists of beta alanine here. This tail here is alanine, and the head is pentoic acid. So alanine and pentoic acid, you have pantothenic acid. All right, part of acetyl CoA, of course, because it's used to synthesize coenzyme A. So this pantothenic acid is part of coenzyme A. So consists of pantothenic acid. So acetyl group here, pantothenic acid in the middle, and then phosphorylated ADP. These all, made up of, coenzyme A. It's a long structure. I don't expect you to remember to draw this coenzyme A structure. It's not really, important to draw it. But the most important thing that what made up of what make coenzyme A. We have to know that acetyl group here, pantothenic acid in the middle, and then phosphorylated ADP. So you have it here, coenzyme A. The important roles of coenzyme A: acid group carrier, of course, CoA, you know, it's an acid group carrier to form acetyl CoA. Without CoA, you cannot transfer this, you cannot transfer it to acetyl, and hence you cannot have acetyl CoA. That's why we need coenzyme A. So, acyl carrier group to form acyl CoA, transport carbon atom within cells. So, during carbohydrate metabolism again, how the CoA is being transport to one molecule to another. In energy metabolism, pyruvate to enter TCA cycle, so alpha ketoglutarate to succinyl CoA. Without this will not going to exist. So, and biosynthesis of many important compounds such as fatty acids, cholesterol, acetylcholine, and etc. There's so many things more than this, but this is the three most important, compound that being synthesized with coenzyme A. Other than that, such as acetylation, signal transduction, deamination, and so on. All right. All right. Vitamin B5 can be found in nearly every food. It's most of the food contain vitamin B5. High amount in avocado, whole grain cereals, legumes, egg, meat, jelly, yogurt, and so on. Deficiencies similar to other vitamin B. You can have irritability, you can have fatigue, apathy, not enough energy, lethargy. Acetylcholine synthesis is also impaired. So without coenzyme A, you cannot have acetylcholine. Therefore, neurological symptoms can also appear. So acetylcholine is, neuron activator that give a signal in neuron metabolism. So without acetylcholine, without enough acetylcholine, or even without acetylcholine, you cannot have this properly neurological mechanism or metabolism. So again, toxicity is very rare. So up to now, from vitamin B1 until vitamin B5, only one vitamin that have reported to have toxicity. So what vitamins are there? What vitamin is it? Can I ask Nur Azira?
Niacin.
All right, thank you very much. Only niacin, only niacin has been reported to have slightly, adverse effect when you take it in excess. The rest, up to vitamin B5, the toxicity is very rare. Okay, next we go to vitamin B6 or pyridoxine. Pyridoxine is slightly complicated because it's not only contain not it contains more than normally the vitamin that we already discussed from vitamin B1 up to vitamin B5. It's either only have one or two, cofactor. But vitamin B6 it contains 7 forms, which is pyridoxine, pyridoxine 5-phosphate, pyridoxal, pyridoxal 5-phosphate, pyridoxamine, pyridoxamine 5-phosphate, and pyridoxine acid. So it is slightly harder to memorize this vitamin B6, but I'm sure that you can memorize all these names. So 7 forms that I just mentioned. So this is pyridoxine, pyridoxal 5-phosphate, pyridoxamine. These three I just give example. All right, so we go to pyridoxal 5-phosphate, which the most active form of vitamin B6. The most metabolically active form drives approximately 168 vital enzyme processes in our body. So we know that vitamin B6, it contains 7 forms, but the most active form of all these 7 is pyridoxal 5-phosphate. This is how do we know that this is the most active form? You know, when the scientists, try to extract this vitamin in our body, by using not extract. You can take your blood as a marker to identify this type of vitamin in your body. They can identify that what type of form that this vitamin exists in your body. So they found out that this pyridoxal phosphate is the most metabolically active form. So all of this, by taking all of these marker for this 168 vital enzyme process, for example, energy transamination, decarboxylation, all of this enzyme required pyridoxal 5-phosphate. So that's why they come out that this is the most metabolically active form of vitamin B6. So there's a lot, 168. I don't memorize all of these, 168, which is quite very, very, too much. All right. Coenzyme in all transamination reaction and certain decarboxylation and deamination. So can you imagine that all transamination reaction requires pyridoxal phosphate? There's a lot of transamination reaction going on as we speak now in our body. And certain decarboxylation and deamination. Deamination, transamination reaction, which, from one compound, one molecule transfer the amine group to another molecule, while deamination, the removal of amine. So essential for red blood cell metabolism as well as hemoglobin formation. Essential, the word essential again is very vital for red blood cell formation. The nervous and our immune system needs this vitamin B6 to function efficiently. Needed for the conversion of tryptophan to niacin. Okay, so if you want to convert niacin, you need this vitamin B6. Without vitamin B6, your body cannot convert tryptophan to niacin. So it's important. Maintain blood glucose within a normal range. When calorie intake is low, vitamin B6 helps to convert stored carbohydrate or other nutrients to glucose to maintain normal blood sugar level. All right. And the other vitamin B1 up to B5, they're important, but they are not, play a vital role in when the calorie intake is low. Like vitamin B6, when the calorie intake is low, when you don't have enough diet. For example, during our Ramadan, we are fasting, right? So during that time, how many hours, we don't have any food to get in our body, so calorie intake is very low. So this vitamin B6 is responsible to convert all these, stored carbohydrate and other nutrients to glucose to maintain our blood sugar level. So it's also important in lipid metabolism. Biosynthesis of 5 important neurotransmitter: serotonin, dopamine, epinephrine, norepinephrine, gamma aminobutyric acid. So important neurotransmitter required vitamin B6 in order to synthesize them. So you can imagine this B6 is very important. So what else vitamin that's important for neurotransmitter? I think vitamin B5, right? The rest, vitamin B1, B2, B3 is not involved in neurotransmitter, but the vitamin B5 important for acetylcholine synthesis, but even important vitamin B6, which for the synthesis of 5 important neurotransmitter. Vitamin B6, you can, the food that contains lots of vitamin B6, fortified breakfast cereal, turkey, beef, banana, potatoes, pistachio. There's a lot of other type of foods you can, Google yourself that we eat every day. Even you have it at home by now, but this, I list here contain high amount of vitamin B6. We don't, normally eat turkey. Beef, of course, we just eat beef a couple of, during Hari Raya. To now, I think most of us still eating beef rendang and so on. Bananas, okay, it's easy to get access for banana. Potatoes, pistachio, it's not that common in Malaysia. All right, so no problem for us in order to have access to vitamin B6. So we can, we can have relief that, because it's not that hard to get vitamin B6. We don't need to take supplement. We just eat as our normal food. Will be good. Will be fine. So how about the deficiencies of this vitamin B6? For skin dermatitis, all right, you can read here. Because it's important in synthesis of 5 neurotransmitter. You can have neurological abnormalities when you have deficiencies of vitamin B6. Depression, confusion, convulsion. Vitamin B6 also can cause anemia. Why? Because it's important in order to synthesize red blood cells. So without this, you can have anemia. Okay, next, I think we have another 5 minutes. All right, next, vitamin B7 biotin. Formerly known as vitamin H or coenzyme R. I can't remember the story of this vitamin H and coenzyme R. Maybe I can share the next class, or you can Google yourself. I forgot about the history of this vitamin H. This vitamin B7 or biotin is a prosthetic group for enzyme involved in metabolizing fats and carbohydrate, as well as in amino acid metabolism. So this is biotin. Biotin contains valeric side chain, COOH. Valeric is short chain fatty acids, or valeric is a branch short chain fatty acid. We don't have a lot in our body. We can have valeric acid from our diet by eating dietary fiber. You eat a lot of dietary fiber. The bacteria in your gut will metabolize this dietary fiber, will give you short chain fatty acid and some very low amount of valeric acid. So biotin. D-biotin is a cofactor responsible for carbon dioxide transfer in several carboxylase enzyme. So 1, 2, 3, 4, 5, this carboxylase enzyme requires biotin as a cofactor. Acetyl-CoA carboxylase alpha, acetyl-CoA carboxylase beta, methacronyl-CoA carboxylase, propynyl-CoA carboxylase, and pyruvate carboxylase. All of these which is responsible for energy production. And then let's see how we can get this vitamin B7 from endogenous source by gut bacteria I just mentioned. That is why I always say to my student, to you, to my family, I always tell them to try to eat lots of fiber. it's not that easy. It's not, you know, really hard, but it's important. You know, we think that, you know, our body, you know, we are human, but if you do what you call it, genomic analysis, you know, you can see that our body mainly consists of trillion is not, it's not a billion, it's trillion, more than 100 trillion bacteria. So some scientists before call us not 100% human. You know, our body is made up of 100, more than 100 trillion bacteria. So lots of the, you know, mainly come from our gut. It's gut bacteria. All right, this gut bacteria, you know, may seems to have, you know, we think that it's not really, it's important, but not really very important. Instead, this gut bacteria is extremely important. I've been stressed this lot to, you know, even to my family. I think I told them, you know, we need to add lots of fiber. Why? Because we need to give food to the bacteria that we have in our body. Like you have your pet at home. You need to give your kid, cat, dog food every day, right? But you know, we love our cat, we love our dog. If you have dog at home, we love our maybe hamster. That's why you feed them proper food. And some people even spend thousand for, you know, for their pets, just for food, right? But how about our body, the bacteria that really important, that really regulate, you know, our body health, the gut bacteria. That's why we need to give them a very proper food. You know, what type of food that this gut bacteria love? It's a fiber, right? You can eat lots of that cereal. You can eat fruits, vegetable. I don't eat lots of vegetable, but I try to, you know, to substitute the vegetable to fruit because I like to eat fruits. You know, mango. You can eat banana. You can eat apple. You can eat whatever fruit that you like. Try to eat it a lot every single day. You know, so this is not, you know, we know that the fruits contain lots of vitamin, which is for you, right? But even important that the part of the fruits that contains fiber, fiber is dietary fiber, is undigestible. Dietary fiber cannot be processed by your intestine, so straight away goes to your gut. Whereas, you know, as a food for this bacteria will metabolize. We will take this dietary fiber that cannot be digested by our body. They they'll be processing this type of food material for their, you know, for their growth, for their you know, for their growth, for their environment. In return, the byproduct of this metabolism will give us short chain fatty acids, will give us choline, you know, that are very important in our body. Right. For example, this vitamin B7, this gut bacteria produce valeric acid. You know what we just mentioned about this vitamin B7, important for, responsible for this, all of this enzyme. All right. So other than that, this gut bacteria produce short chain fatty acid for your, you know, for your gut health. You know, to prevent from you have a colon cancer. To prevent you from having like ulcer in your colon and so on. All right, so that's why the gut bacteria, we have to take care of our gut bacteria, not only our pet at home. All right, so that's why eat good food, with good quality food that contain fiber. Please not only, you know, please don't eat something that can kill the gut bacteria. The processed food, you can eat processed food once a while, not every day, not, you know, once a week. I think it's fine. All right, so apart from that, liver, meat, egg yolk, mushroom, milk, and dairy product deficiency, brittle, thin fingernails, hair loss, conjunctivitis, dermatitis, neurological symptom. Again, same goes with vitamin B6. Long-term consumption of raw egg also can cause vitamin deficiency. Okay, so long-term consumption of raw egg. Raw eggs contain something that called I can't remember. Uh, I will get to you on tomorrow if I remember. It's some molecule compound that that can cause biotin deficiency by prevent your body from absorb this biotin. It's kind of like it's hiding this biotin from your body. When you eat something, your foods contain biotin, for example. But when you eat raw egg, for those who goes to the gym, who used to eat raw eggs, for long term, it's not like if like 2-3 months is fine. But if you've been doing this for more than that, more than 1 or 2 months, it's quite dangerous, because this raw egg contains compounds, I can't remember the name, that can just they try to hide this biotin from being absorbed by your body, so your body will have biotin deficiency. All right. I will finish up to biotin. Right, folic acid. It's already 3 o'clock. Do you have class after this? You still with me? You have
Yes, sir.
class? Okay. All right. All right. I think we stop now.